We're going to spend our second day in section 8.3 still talking about linear functions, but a different way to graph linear functions. So two vocab terms, please make sure you write these down. The first one is the x-intercept. The x-intercept refers to the x-coordinate of the point at which the graph crosses the x-axis. The y-intercept then is the y-coordinate of the point at which the graph crosses the y-axis. And we're going to use the x and y-intercept today to help us graph linear functions. Also, we should note that since 2 points determine a straight line, this is a simple method of graphing a linear equation. We'll be finding points where the graph crosses the x and y axis and then connecting them. So first, let's look at a couple graphs and let's discuss what the intercepts are. So the x-intercept, remember, is the point where the graph crosses the x-axis. So if we look at the graph on the left, you see the x-axis, remember it runs horizontally, and we have the graph, the function, the linear function, intersecting here. If I asked you to name that point, you would probably name it as -2, 0. That's the point where the graph crosses the x-axis. Therefore, the x-intercept, and I'll abbreviate it using x-int, is -2. Because it's the x-coordinate of the ordered pair, or of the coordinate point, where the graph crosses the x-axis. Note that the y-coordinate of that ordered pair will be 0, since we are on the x-axis. Similarly, if we talk about the y-intercept, now we're focusing on the point where the graph crosses the y-axis. And if we were to name that point, we would name it 0, 3. Remember that the y-intercept then is the y-coordinate of that point. So that would be 3. Also notice that the x-coordinate of that point is 0. So for the x-intercept, we have -2, 0, and for the y-intercept, it's happening at 0, 3. Let's look at the graph on the right. First, I would like you to pick out the x-intercept. Locate that point on the graph. Hopefully you're focusing here. Remember, this is the x-axis, and we would name that point 7, 0. So the x-intercept is 7. The y-intercept is again where the graph crosses the y-axis, and that's occurring at 0, -3. Remember, when we name a point, we're starting at the origin. You move horizontally first and then vertically. So the y-intercept is -3. So when looking at a graph, are you able to pick out where the x and y-intercepts are occurring? Let's look at our objectives for this lesson also. One, we want to be able to locate and name x and y-intercepts on a graph of a linear equation, and that's what we just did in the previous slide. We also want to be able to find x and y-intercepts given a linear function, and we want to be able to graph a linear function using those x and y-intercepts. So let's look at an example that deals with the last two objectives. So we're asked to find the x and y-intercepts of the linear equation -2x plus y equals 4. Then we're going to graph using those intercepts. So it doesn't matter which one you find first. You can find the x-intercept first or the y-intercept. I'll go ahead and find the x-intercept first. Remember, when we label the x-intercept, when we name that ordered pair, the y-coordinate of that point was always 0. So in order to find the x-intercept, we are going to make the y a 0. We are going to plug in a 0 for y. That will tell us what the x value is at the x-intercept. So now we need to simply solve this equation. Well, -2x plus 0 is just -2x. And now we solve by dividing by -2, and we get that x equals -2. 4 divided by -2. So our x-intercept is -2. We want to do the exact same thing for the y-intercept. Except remember, for the y-intercept, it's the x-coordinate of that ordered pair that's 0. So now we want to make the x 0. Notice I'm plugging in a 0 for x, and then we'll solve for y. Well, negative 2 times 0 is 0. If you add 0 to anything, you just get that. So 0 plus y is y. We end up with y equals 4. So now we have the x-intercept at negative 2, and I'll graph that on the x-axis. And we have a y-intercept of positive 4. So graphing using the intercepts, once they're plotted, you simply connect the dots. Let's look at another example. We have negative x plus y equals negative 4. We want to find the intercepts and then graph. So for the x-intercept, we're going to again make y 0, because that's the coordinate at the x-intercept. The y-coordinate is 0. Negative x plus 0 is just negative x. Remember, this is an implied negative 1, so we need to divide both sides by negative 1. And we get x equals positive 4. So our x-intercept is positive 4. And I went ahead and plotted that over on the graph. For the y-intercept, remember we want to make x 0. So we're plugging in a 0 for x. This essentially is negative 1 times 0. Remember, when there's a negative out in front, it's really a negative 1. So we just get 0 plus y equals negative 4, or just y equals negative 4. So our y-intercept, our function, our graph, is going to cross the y-axis down at negative 4. Again, we just need 2 points really to graph a line, so now we can connect our intercepts. And we see what the linear equation would look like on a graph. One more example here. I'd like you to try this one on your own. So try to find the x and y intercepts, and then graph the equation using the intercepts. So please pause the video. We have x-intercept found by making y 0. X plus 0 equals 2. I'm plugging in a 0 for the y. We get x equals 2. To find the y-intercept, we plug 0 in for x. 0 plus y is y, and we get y equals 2. So the graph crosses the x-axis at positive 2 and the y-axis at positive 2, and we can connect our dots to draw the line. So can you locate and name x and y intercepts on a graph of a linear function? Go back to, I believe it's actually maybe the third slide, that had the 2 graphs on it, where we were looking at the equations and circling and labeling where the x and y intercepts were. If you understand that, then you can locate and name the x and y intercepts. Can you find x and y intercepts given a linear function? That's what we did on examples 1 through 3. And then finally, we were able to graph using those x and y intercepts. In class, we'll work on worksheet 8.3b.